Welcome to problem sheet 1 for ELEC120. This is the solution to question 1 part B on problem sheet 1. So question B asks, with the aid of two labelled diagrams, show how the electrostatic field lines and equipotentials in space for the following systems. So first up is a point charge with a charge of positive Q, and the second you need to do is a solid sphere with a total surface charge of minus Q. So this relates to this section of the lecture notes. Essentially, if it's a point charge and it's positive, the field lines radiate outwards, and if it's a negative point charge, the field lines will radiate inwards towards it. So first one you need to do is, this is the point charge, this is the field lines. Essentially a point charge is really, really tiny. So let's look at the solutions for that. So here we go, point charge plus Q, and the positive sign gives us the direction of the field lines, so we know they're going to go outwards from our point charge. So here's our tiny, tiny little point charge. That's as small as I could make it with it still being visible. Don't worry too much about how well you draw this, just make it so you can see it really. Okay, so the important points here are that the electric field lines radiate uniformly from the point charge positive Q. So that's the first part, that's the field lines. Now we need to do the equipotentials. Now equipotentials are the, they come down to, where have we got it in the lecture notes? Equipotentials are a bit later on in the lecture notes. They are these things. Equipotential lines show contours of equal potential. So along this dashed line, the electric field strength is the same. And that's essentially what we need to do in our answer. So they're perpendicular to the field lines, and there are more of them when they're actually close in and fewer of them further out, just because the electric field strength changes more closer to the charge because it's stronger there. But you don't need to show that in your answer. All you need to show is that they're perpendicular to the field lines. So the dashed lines are the equipotentials and they're perpendicular to the field lines. That's the important point. So that diagram, 2 marks. Right, next up we're going to look at our solid sphere with a surface charge of minus Q. Well, the minus is going to tell us that the field lines, the electric field lines, are going to go inwards towards the solid sphere. So essentially it's very similar to a point charge, it's just that the charge is bigger. So I'm going to show you what the answer to this one is. So if we go down, here we go, minus Q, so that's the direction of the field lines. The field lines are going inwards. So I've drawn E, my field lines are going inwards. And here is my solid sphere. Don't go overboard with the size of it, just make sure that it's bigger than your point charge. And that's what you can see going on here. So the point charges aren't, if it was a point charge, these lines would extend down into the centre, but we don't need to do that. And once again, we've got equipotentials, which are perpendicular to the field lines, and they just show the contours where the field strength is the same. And because it's a solid sphere, because it's a sphere, basically it's just a larger version of a point charge, so our equipotentials are spherical again. And that is the answer to question 1b.